Hello, hello, hello. I am here to go through some review problems with you, and we'll just see how this goes. If you would start with number 11, you can, first of all, let's name this matrix, these matrices actually, to see what if they multiply and what the result might be. So this is a 2 by 3 that's being multiplied by a 3 by 2. What has to be the case for these to be, for us to be able to multiply them, is that these numbers have to be the same, and they are. So what does that mean about the dimensions of the product when we multiply these? It will be a 2 by 2. So how does that work? Well, all of these numbers are going to multiply by all of these. And then all of these numbers are going to multiply by all of these. And that'll give us the first two. So let's do that part. So blue times blue. 5 times 2 is 10, plus 5 times 0 is 0, plus 5 times 4 is 20. And then we can do, there's a fly in here taunting me. Four times 5 is 20. Plus 0 times 2 is 0. Negative 4 times 6 is negative 24. All right, and now we need to do this one times this one. 5 times 5 is 25, plus 5 times 2 is 10, 30. I'm going to go ahead and start calculating this. 30, 50, 65. Negative 4. E is looking pretty promising. Let's do the last one. 4 times 2 is 8. So this times this. 0 times 0 is 0. Negative 4 times 4 is negative 16. So this becomes minus 8. And it does look like it's E. Now, there's a lot of knowledge that has to be had there. Your calculator can help you with this if you can hit alpha zoom and create some matrices for yourself. So let's do a 2 by 3. 5, 5, 4. Yeah. -4. Now we're going to multiply it by another matrix. 3, 2. Okay. 2, 5. 4, 6. And we get the same thing. Okay. So matrices, use your calculator. I want you to know how to do them, but calculator is a great friend. Number 12. I would say on this one, it's almost more trouble than it's worth to put them in the calculator, because all you have to do to add matrices is they have to have the same exact dimensions, because you have to do 3 plus negative 1 is 2. 6 plus negative 6 is 0. 2 plus negative 2 is 0. Negative 3 plus 2 is negative 1. And then you multiply all those numbers by 4 and you get 8, 0, 0, negative 4. Boom. 8, 0, 0, negative 4. C. Easy, easy. All right, we did a dilation already. Now let's look at let's look at this, x, y, v, w. So this is -1, 3. I'm going to write the original points. This is 0, -1, -2, -4, -4, -2. Dilations are easy, just multiply back to 13. Just multiply each point, each coordinate by the dilation factor. Rotations are a little more difficult. So if we were to take these vectors, so this is a 1, 0 vector, and this is a 0, 1 vector. Those are just the unit vectors, and all of these points, x, y, v, and w, are made up of these unit vectors, just multiples of them. So if we were to rotate these 180 degrees, this green one would be pointing this way. It would be -1, 0. And this red one would be pointing down. It would be at 0, -1. Not this one, not this one. So the x component needs to be made negative, and the y component needs to be made negative. So what will happen is this would become 0, 1. This point would go up here. I'm going to erase some things. Zero, 1. This point would become 1, -3. 1, -3. So this is x prime. This is y prime. V would become 2, 4. 2, 4. V prime. And this would become 4, 2. 4, 1, 2. W prime. And it looks something like this. Same shape, it's been rotated 180 degrees. All right, some basics of matrices. We did this when we did the matrix review. So just straight from there. If you multiply a 2 by 2 and a 2 by 3, well, you can't, because those center numbers have to be the same. The number of the column and the number of rows as you multiply them have to be the same. So this is impossible. If you multiply a 2 by 2 and a 2 by 4, however, those numbers are the same. So the answer is a 2 by 4. Multiply a matrix by its inverse, you're going to get an identity matrix. And you have to, if you want to find the inverse by hand, you need to know the determinant. Moving right along to that one in class. Put those in class. Why would you want to use a sequence instead of a function to model a scenario? We talked about how you got like your y equals mx plus b. That's a function. And then you've got any term equals n plus term 0. So it's like term 0 is the y-intercept. N, well, d is actually the slope. And x is the term number. So it's like all the parts are the same. So why would you use one instead of the other? Because functions limit the domain to integers like many real world situations do. Close, but functions don't do that. Actually, sequences do that. Sequences limit the domain to integers like many real world situations. That's the truth. You're talking about a theater full of seats. A function would tell you that on the 13th and a half row, you have, 470.2 seats. That's not how the world works. We don't have 0.2 seats and we don't have half rows. So sequences are really good for real world situations where things can be counted. A sequence is capable of finding the value at a certain point, and functions are capable of finding values at certain points. So both of those are wrong as well. All right, let's look at 22. Drop a ball from a height of 20 feet. So it's 20 feet above the ground. Here it goes. And then it's going to bounce back up. It says it bounces back up to 80% of its previous height. And n equals 1 represent the height the ball reached before the first time it hits the floor. So this is term 1. Term 2 then, so if term 1 is 20, let's see what term 2 would be. 80% of 20 is just 16. What's 80% of 16? That would be 12.8. So that's the way the ball bounces. Bounces up again. So let's see what all of these will model my scenario. The explicit formula for a geometric sequence is what this is, because we're multiplying over and over again. So this is geometric. Would be it would be the 0th term times the ratio to the n. So what would have come before 20 would be 25 times the ratio 0.8 to the n. So it looks to me like the first one works, but don't take my word for it. Here's what I want you to do. Do as I say and do, not as I do. Okay, so if I want to know what the first term is, then I would plug in a 1 for n, and it tells me it's 20. Well, that's good news because the first term is 20. So I know that that works. Does it work for the third term? 12.8, that's what I said it was. So it works for the function. And that's really all I need to know, that it works for this sequence of numbers. Let's try the next one, 20 times 0.8 to the third. That should give me the third term. Well, it doesn't. That's not the third term. So B can't be true. Let's try the other equation while we're here, equation D. And that may look different to you. It may, because it has a subtraction in the numerator. That's just a shift, a horizontal shift to the right 1. It looks a little different with exponential functions, but so if I want the third term, I plug in 3 for n, and let's see what happens. Whoops, this is supposed to be an exponent. I'm not going to do it. Boom, 12.8. So that one actually does give me the right number. How does it do that? Well, it's basically B, the answer to B, except it subtracts 1 from every one, so from every term. So the first term in the equation, it does 1 minus 1 and gives you 0, so that's actually the first term. It's a sneaky way to be able to use term 1. So D is also true. Well, after the ball hits the ground the 5th time, will it go more than 5 feet into the air, or 10 feet into the air? Let's see. So the 5th, when after the ball hits the ground the 5th time. So this is the first time it hits the ground, then it goes to n2. The second time, n equals 3. So the 5th time it hits the ground will be term 6. Will it go more than 10 feet in the air for term 6? I'm going to use A's equation because it's easy. Boom, it doesn't go anywhere near 10 feet in the air. We'll go more than 5 feet in the air on the 7th time. That would be term 8, 25 times 0.8. No, it doesn't go more than 5 feet in the air. So it's just A and D. That's all we've got. William starts a career with $40,000. That is, I'm going to call that term 1. That's his beginning. You could also just think of this as an exponential function, which we've done as well. He gets a yearly raise of 2%. Approximately how much will he make in his 10th year? Let's see. So his 10th year, how many raises will he get in his 10th year? So if he's right now in his first year, he hasn't got a raise yet. So his second year, he'll make 2% more than that. So you would do, we could find out what 2% of 40,000 is. It would be 800. So you make 40,800. So what's happening here? How am I getting from year to year? I'm multiplying by something. It's not 0.2. It's not 0.02. It's not 2. It's 1.02. Why is it that? Well, let's say if he's making 40,000 and we do 0.02 of that, that gives us the 800. That's his raise. So it's not that he just gets 800 the next year. That would stink. We'll quit that job. He's going to make 800 more than he made the first year. So when we multiply this, we actually need to multiply it by 1.02, where the 1 gets him back his original amount, and the 0.02 is his raise on top of that. And then you can multiply by 1.02 again, and again, and again, and so on and so forth. So you see the next one, 41,616. He actually makes more than $800. He has more than $800 raise in his next year because his raise got a raise. The money he increased after his first year also gets 2% on it. So I'm going to make an equation for this. There's a couple ways you could do it. You could say AB to the X, where A would be his starting amount, B would be 1.02, and then what's the X? The X is the number of raises he gets. So this is one raise, this is his second raise. So in his fourth year, how many raises has he gotten? 3. So it's actually X minus 1 would give us that. If you think of it as a sequence, any term is equal to the 0th term times the ratio to the n. So we would need to do 40,000. Say, if there was a 0th year, how much would he make? 39,215. 0.69 times 1.02 to the n, or to the x. So we could just put, if we want the 10th year, we can do that and just put a 10 in right here. Same thing over here, I could put a 10 in right there. Let's see what happens. Times 1.02 to the 10th. In his 10th year, he should make $47,804, give or take. But I can also do my original equation, 40,000 times 1.02 to the, what's 10 minus 1? It's 9. You see they're the same. 47,803.7. 47,803.7. 70 cents. It's all about that 70 cents right there. All right. I know you love that. There we go. That's 23. 24, we can talk about that in class if we need to. We will continue in another video with some more matrices.